All right, let's dive into something really cool. What if I told you that the physical wiring of your brain, the way it's actually built, might be a direct result of some very pure, very abstract mathematical laws? Today, we're going to connect those dots between math and neuroscience and find what looks like a hidden blueprint for intelligence itself.
So it all kicks off with this really fundamental puzzle from biology. You see, when we look at the circuits in the brain's cortex, they're not a one-way street. Information flows up, but it also flows back down. It's this constant bidirectional highway. The question is, why? Why is it built that way?
And here's the wild part. The answer doesn't seem to come from just studying more biology. It looks like it comes from a place that you'd never expect. The super abstract world of mathematics. The math of pure structure. Think of this as a detective story. And our clues are these universal patterns that show up in the strangest places.
Okay, for our first big clue, we need to kind of shift our thinking. Let's stop picturing the brain as just a fancy computer for a second and start seeing it for what it is, a self-regulating cybernetic system.
So what is a cybernetic system anyway? It's not just something that gives orders. It's a process that's locked in a constant two-way conversation with everything around it. It has to sense what's going on, act on it, and then adjust based on the results, all just to keep itself in balance. That back and forth, that bidirectional flow, that's the absolute key.
You know, the simplest way to get this is to think of a thermostat. It senses the room temperature, that's the environment, and then it acts by kicking on the heat to get back to where it wants to be. It's a simple little loop of sensing and acting. Well, our brain is doing basically the same thing, just on an unbelievably complex scale. And this idea, it's not some niche thing. It is everywhere. It's the engine that lets an AI learn from its mistakes. It's how players in a game adapt their strategies on the fly. And of course, it's how every living thing, from a single cell to us, adapts to a changing world. It's all built on that same two-way feedback loop.
Okay, so the brain is a self-regulating system. Got it. But how does it do that? How does it actually regulate itself? This brings us to our second clue, which is all about the brain's incredible, maybe even primary job, predicting reality.
And this brings us to a really powerful theory called active inference. The core idea is that your brain isn't just sitting there passively soaking up information. No, it's an active prediction engine. It's constantly building a model of the world, guessing what's going to happen next, and then you act in ways to make reality match your predictions. It's all about one goal, making the world less surprising.
And what's the mathematical engine running this whole predictive show? It's something called Bayesian inference. It's basically the formal rules for how to update what you believe when you encounter new, messy, uncertain evidence. It's the math of reasoning. Now, here's where it gets a little weird and really interesting. When mathematicians dug into the deep, fundamental structure of this Bayesian process, they came up with this very strange-sounding statement you see here. Bayesian updates compose optically. I know, it sounds like nonsense right now, but trust me, this weird little phrase is the key that's going to unlock this whole mystery. Stick a pin in that.
So to crack that cryptic quote, we need the master key. And it's a field of pure mathematics called category theory. You can think of it as a kind of universal language for describing patterns and structure.
The thing about category theory is that it's not so interested in what things are. It only cares about how they're structured and how they connect to other things. It's like a language for blueprints. It can describe the shape of almost any system, whether it's in physics or coding or, even biology.
And this lets you see something pretty mind-blowing. It lets you see that systems that look totally different on the surface, say an AI learning to play a game and a cell regulating its own metabolism, can actually share the exact same underlying abstract shape. Category theory gives us the special glasses to see these hidden connections. So inside this giant mathematical toolbox, there's one specific tool that's just perfect for our puzzle. It's called a profunctor optic. Now, don't worry about the name, it's a mouthful. Just think of it as a mathematical lens designed for one specific job, to model systems that have a two-way flow of information. And that is the optic from our cryptic quote. It's the bridge that's going to take us back to the brain.
All right, let's take a breath. We have all our clues on the table. We've got the two-way streets inside the brain, we've got the brain as a self-regulating system, and now we have this weird mathematical lens that's also all about two-way flow. It's time to put it all together. So this is it, the final question. We have this super abstract mathematical thing, an optic.
And this very real, physical, biological thing, the circuits in our brain. What on earth is the connection here?
And here it is. This is the big reveal. On the left, you've got physical reality, the two-wire circuits we actually find in the brain. And on the right, you've got a pure mathematical abstraction, the optical structure of Bayesian learning. The huge discovery here is that these two things aren't just kinda similar, they are describing the exact same abstract shape. The physical biology is a perfect embodiment of the ideal mathematical form.
So here's the bottom line. The math isn't just a neat description. It actually provides a deep reason for why the brain is built this way. It turns out that the most efficient, the most optimal way to build a system that learns and predicts using Bayesian logic is with this two-way optic shape. Biology, through evolution, figured out this fundamental mathematical truth.
And this discovery goes way, way beyond just our brains. As the researchers put it, you start to see that all these totally different ideas share this profound secret. They're all built around the same fundamental abstract shape.
So this isn't just a story about biology. We've stumbled onto a kind of universal blueprint for any intelligent, adaptive system. We see it in our own minds, sure, but we also find it in the architecture of our most advanced AI, in the theory of cybernetics, and even in cutting-edge methods for making sure complex software works. They all independently discovered the same optimal design. Which leaves us with this one last pretty mind-bending question. If Mother Nature, through billions of years of evolution, and us, through our own engineering, have landed on the exact same abstract design for an intelligent system, what does that tell us about the future? Are we just starting to scratch the surface of the universal laws for how to build a mind, whether it's made of cells or silicon?